Question 6, Part B. A rare species of bird lives only on a remote island. A mathematical model predicts that the bird population, P, is given by P equals 150 plus 300 times e to the power of negative 0.05 t, where t is the number of years after observations began. Part 1. According to the model, how many birds were there when observations began? Observations began at time t equals 0. Substituting 0 for t into the model, we have p of 0 equals 150 plus 300 times e to the power of negative 0.05 times 0. And that equals 150 plus 300 times e to the power of 0, where e to the power of 0 is equal to 1, and 150 plus 300 times 1 is equal to 450. Therefore, there were 450 birds when observations began. Part 2. According to the model, what will be the rate of change in the bird population 10 years after observations began? The rate of change of the population is given by dp dt. So given that p is equal to 150 plus 300 times e to the power of negative 0.05 t, differentiating p with respect to t, we get dp dt is equal to 300 times e to the power of negative 0.05 t times the derivative of the index, which is negative 0.05, and that gives us negative 15 times e to the power of negative 0.05 t. Now at time t equals 10, the value of dp dt is equal to negative 15 times e to the power of negative 0.05 times 10, which equals negative 15 times e to the power of negative 0.5, which evaluates to negative 9.0979, and so on. Interpreting this result, we get the rate of change of bird population is predicted to be a decrease of 9 birds per year 10 years after observations began, correct to the nearest whole number. Part 3. What does the model predict will be the limiting value of the bird population? The limiting value of the population is approached as t approaches infinity. So p of infinity is equal to 150 plus 300 times e to the power of negative 0.05 times infinity, which equals 150 plus 300 times e to the power of negative infinity, and e to the power of negative infinity approaches 0. And we can see that if we observe the graph of y equals e to the power of negative x. As x gets really large, e to the power of negative x approaches the x-axis. And that equals 150. Therefore, the limiting value of the bird population is predicted to be 150. Part 4. The species will become eligible for inclusion in the endangered species list when the population falls below 200. When does the model predict that this will occur? Letting the population p equal 200, solve for t the equation 200 equals 150 plus 300 times e to the power of negative 0.05 t. Subtracting 150 from both sides of the equation, we get 50 is equal to 300 times e to the power of negative 0.05 t. Dividing both sides of the equation by 300, we get 1 over 6 equals e to the power of negative 0.05 t. Taking the natural logarithm of both sides, that is log base e of both sides of the equation, we get ln of 1 over 6 is equal to negative 0.05 t. This is to eliminate this raising to the base e on the right-hand side. Rearranging this equation to make t the subject, we get t is equal to ln of 1 over 6 divided by negative 0.05, which equals 35.835, and so on. Interpreting this result, therefore the population is predicted to fall below 200 in the 36th year.